Hi, in this video we are going to see about a Python IEEE project which is entitled as Malware Analysis and Detection Using Machine Learning Algorithm, which is an enhancement of IEEE base paper title Intelligent Pattern Recognition Using Equilibrium Optimizer with Deep Learning Model for Android Malware Detection, which is an IEEE 2024 journal paper. Before seeing the execution of the project, let me brief about this project. So generally we all know about the malwares in the PCs or computers or the laptops. So those malwares are the specialized softwares that is designed to damage your PC or your laptops. So here they have done with the Android malware. So we all know that the number of smartphone users are increasing day by day all over the world, and when considering the number of users, Android operating system is more when compared to the other operating system. So whenever there is a large number of users, there is also a threats in this cyber world. So to overcome and prevent these kinds of threats, we have the cyber security. So in the cyber security, Android malware detection plays an important role. So in the base paper you can see the authors have mentioned about the Android malwares, like malware especially associated with an Android operating system has been recognized as Android malware that damages or takes information in an Android based mobile device. So these are considered like ransomware, adware, botnet, spyware, worms, backdoors and trojans, etc. So in this base paper, the authors have developed the Android malware detection using intelligent pattern recognition, that is particularly using equilibrium optimizer with the deep learning approach. But kindly note that we are not going to use the same as mentioned in the base paper. So now let us see about what is our proposed system and what is the model that we have used. So in our proposed model, we have used two different models. One is extra tree classifier and another one is logistic regression. So now the question is, what is the accuracy? So in our extra tree classifier, we have achieved train score of 97.42% and test score of 97.23%. And in logistic regression, we have achieved train score of 94.84% and test score of 93.67%. So in the two implemented models, extra tree classifier plays a very good response. So now let us see about the proposed system. So as mentioned, our title is Malware Analysis and Detection Using the Machine Learning Algorithm. So here we have developed using Python, and the project employs the Flask web framework for the backend operations and utilizes HTML, CSS, JavaScript for the responsive and the interactive front-end base. So as mentioned, we have used two different models, extra tree classifier, logistic regression. Those accuracy values are being mentioned. And coming to the next important thing, the dataset part. So here in the dataset part, we have used 4465 dataset records and it contains 242 attributes. So now let me show you the dataset part. So this is the dataset part that we are going to use. So you can see the dataset contains 4465 dataset records, and as mentioned, we will be using 242 attributes are available in it. So these are the attributes: access all download, access cache file system, access check-in properties. So these are the 242 attributes that is available in the dataset part. But kindly note, we are not going to use all the dataset, so all the attributes that is available. So in the dataset part, we'll be using 23 attributes that is selected relevance to the classification task, and we are going to implement it. So coming to the existing system of the project, as mentioned, we are considering the base paper as the existing system where they have used the equilibrium optimizer with the deep learning approach. So those details have been mentioned in the existing system part. And coming to the disadvantages of the existing system, so these are the disadvantages like high computational complexity, scalability issue, energy consumption, overfitting risk, maintenance and updates interruptibility, latency issues. So these are the list of disadvantages that is available in the existing system. So coming to the proposed system, we are going to overcome these issues in the proposed system by implementing two different machine learning model, extra tree classifier and the logistic regression. So as mentioned, the data set contains the 4465 instances and 242 attributes. The class it is classified as malware or goodware or malware or benign. So here you can see the accuracy that is achieved, all the details have been mentioned, and here you can see the list of advantages of proposed system, which includes high accuracy, efficiency, detection, user-friendly interface, scalability, flexibility in the model, reduced overfitting, integrity, maintenance and update, transparency, resource optimization. These things have been listed out in the advantages part. So this is the system architecture, which contains the input data set, pre-processing feature selection is made, and extra tree classifier and logistic regression model, and printed results we classified as malware and goodware, and performance analysis graph part is done. So, and these are the system requirements, the hardware requirement, the software requirement. So this project can be executed in Windows 10 or 11. The coding language uses Python 3.10.9, and the web framework is Flask, and the front-end part contains HTML, CSS and JavaScript. So this is the reference of the base paper. So now let us execute the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirements file with the exact version of the Python or libraries installed in the system. So now we go to the source code. Inside the source code, we have the malware analysis and detection. Inside that, we have the app.pfl. So now let me open the command prompt. So now in the command prompt, type Python app.py and click enter, and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome and paste it. So now you can see the home screen, welcome screen of the project with the project title, malware analysis and detection using machine learning. So now first click this login menu. Once after clicking the login menu, it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and then click the login button. So now you can see the login is success and click OK. So now it will be navigated to the upload part. So here you need to upload the dataset that is provided in the source code folder. So just go into the source code folder where you can find the upload.csv file. Just select this and then click upload. So now kindly wait for a few minutes. As the dataset records are in more number, it contains more dataset records and the features are more, it takes some time. So make sure that you have sufficient RAM capacity to handle it. So now after uploading the dataset, it will be navigated to the preview part. As my RAM capacity is only 8 GB, it took some time for me. So after that, it will be navigated to the preview part where we can preview the dataset, whichever way I have shown you. This like access all downloads, access cache file system. These details are being shown here in the preview part. So now scroll down to the end of the page. You can see this click to try not test button. Just click it and kindly wait for a few seconds. Now you can see the training finish message and click OK. So now after this, it will be navigated to the important part of the prediction page. So here in the prediction page, we have the important features. So based on these features, it is going to predict the whether it is a malware or benign. It is a good one. So here you can see the features. So as mentioned earlier, the complete data set, the whole data set contains the around 242 attributes, but we are going to use only the 23 attributes. So these are the 23 attributes, like access all downloads, access cache file system, access find location, access network state, access service, access share data, access super user, access Wi-Fi state, camera, change configuration, delete cache files, read attachment, read contacts, read data, read external storage, read Gmail, read history, bookmarks, read messages, read phone state, read settings, read SMS, receive boot completed, receive SMS. And the model that we are going to use, it is going to be extra trees or logistic, whichever you wanted. You can select it and you can make the predictions on it. So let me show you few cases for the Android malware detection. So for the first case, I'll consider the access all downloads as no, network state as yes, all others are no, and phone state at yes, read phone state as yes, and receive boot complete as yes, and receive SMS as yes. So all other cases are marked as no. And let me select the model as extra trees classifier and then click the predict button. So now you can see the prediction result. These are the input data that I have given. So I have given 4 S's, that is access network state as yes, and read phone state as yes, receive boot completed as yes, and receive SMS as yes. So for this, the prediction result is it is a malware, and the model that I have selected is extra tree classifier. So if you wanted, you can just download this data, whatever we have created on prediction result, as a PDF. Just click this download PDF. Prediction 1, I'll just save this in the desktop as prediction 1. You can see the data, whatever the details that were given, what is the prediction, what is the model that we have selected. This can be, the result can be exported. So if you wanted to check with other case, just click the prediction menu again. So now let me show you with the other case. So where it contains the network access network state as yes, read external storage as yes, and all other cases also no. So this time let me select the model as logistic regression and then click predict. So now you can see the prediction result. These are the values that I have entered, and you can see the prediction result is benign, which means it is not a malware, it is a goodware. The model that I have selected is logistic regression. Let me download this PDF and save it as prediction 2. So here you can see the exported result with the features what we are given, model we have selected, and what is the prediction result. So for the scenario, I have shown you with the 2 cases of the benign and the malware, and by selecting the 2 different models. In this way you can check with other cases, that is given from the test case or from the trained dataset model. Now let us move to the next part, that is the performance analysis of the model. Just click this performance analysis menu, it will be navigated to the performance analysis page. Here in this performance analysis page, we have the performance analysis parameter for the logistic regression and also for the extra tree classifier. So in the logistic regression, we have the recall, precision and F1 score for the both the cases of benign and malware, and we have the confusion matrix for true and predicted label of the both the cases. And coming to the next model, extra tree classifier, here we have the performance analysis part. We have the recall, precision, F1 score, similar to the other one we have for this for the extra tree classifier also with the both the benign and malware. And we have the confusion matrix for the extra tree classifier with the true and predicted label of it. and finally comes the chart part. So just click this chart menu, it will be navigated to the chart part. Kindly note that this is a static chart only, as mentioned earlier, as we are not going to use any database in the project, so we cannot show any dynamic chart here. This is a static chart. The first chart contains the accuracy score. So the logistic regression test accuracy score is 93.67 and the extraordinary classifier test accuracy score 97.23. so that is being depicted in the first chart, and second chart contains the representation of the data set that we have used. So here the data set contains 70% of malware data and 30% of the goodware, that is benign data. So that is being depicted in the chart, second chart. So this chart part contains two charts, one is with the accuracy score and another one is the data set classification. And let me log out. And this is all about the project malware analysis and detection using machine learning. And thank you for watching.